Hello everyone, this is Roberto Torre from the Deutsche Telekom Chair of Communication Networks, and today we are going to do our first session of exercises. It's going to be about the prisoner's dilemma from the Cooperative Communication Systems lecture. So let's start with it. Okay. So in the first exercise we had defined the Nash Equilibrium. Remember, I sent you the PDF with the exercises and also the tasks and the solutions. So in this video we are going to solve the exercises. So we had the Nash Equilibrium, we had Bob and Alice. If you remember, the Nash Equilibrium in these cooperative games is the point where all players, any of the players, want to change their strategy, because if they change their strategy they will get a lower reward than the one that they are getting now. So we start with, for example, this is the table of rewards. We see the ones for Alice is the ones at the left, so 7, 5, 3 and 8, and then the ones for Bob is the ones at the right, so 7, 1, 6 and 9. So we can start, for example, with Alice. Okay, she starts with the left strategy, and she can choose between. So let's say, so we can take here the highest points. Okay, so between 7 and 5, we take 7. Then if we go to the right strategy, there are either 3 or 8. So we will circle the 8. So these are the ones these are the best cases in the case that Alice chooses the left one, or in the case that Alice chooses the right one. Now we go to Bob. We have the upper strategy, which is 7. It's either 7 or 6. So in the best case that Bob takes the upper strategy, he will get 7 points. In the best case that he takes the lower strategy, he will get 9 points. Here goes my German. Good. So we can see here there are 2 Nash equilibriums, because none of them will want to change when they reach to these 2 equilibriums, because it's not worth it, because they will win less points. If we, for example, go to Alice, okay, she chooses the left strategy and she's getting 7 points, and then if she wants to swap to the right strategy, she will get 3 points, which is less. Exactly the same for Bob. If we go to the first Nash equilibrium, he's getting 7 points. If he wants to switch to the lower strategy, he will get 1 point. And exactly the same it happens in the second Nash equilibrium with 8 and 9 points. Good. Then let's go to the second exercise about finding the Nash equilibrium. Okay. Then we have here Bob and Alice again with a similar table. So let's start analyzing it. If we go to the left side of the table, we have Alice. With the strategy that Alice, the best case scenario would be either 3 or 4, so we choose 4, of course, this is the highest number. And then if she goes to the right side, she can choose between 4 and 5. She gets, the best case would be 5. In case of Bob, if he takes the upper strategy, he can get either 8 or 3 points, which means that the best case is 8. And then in the lower strategy, he can get either 3 points or 5 points. Of course, the best case will be 5. So if we circle the highest numbers, oh, here's one missing. Anyway, it's fine. So let's see. So what we can see here is that there's only one Nash equilibrium. Okay, let's suppose we start in the upper left corner, in the upper left square. Okay, and we have 3 rewards, 3 points of reward for Alice, 8 points of reward for Bob. Bob's fine there; he doesn't want to change. But Alice sees that if I move to the next strategy, to the right one, I will get 4 points instead of 3. So she changes. And then Alice is getting 4 points and Bob is getting 3. And then either Bob or Alice. So sorry, then Bob sees, okay, so now if I move to the lower strategy, instead of getting 3 points, I will get 5. So I will move. So Bob moves to the down one, to the lower strategy, and now Alice is getting even more points. She's getting 5 points. So now and now of course Bob is fine there. Now Alice thinks, okay, may I move again to the left strategy? Well, if I move to the left strategy, instead of getting 5 points, I will get 4, which is less. So it is not worth it. So she stays there. And Bob also stays there because he moved to that position because it was better for him. And there is how we find the Nash equilibrium. So this is the cooperation strategies that we have. So we have normally, like when we play with 2 players, we have cooperate or defect. And then we have the reward, which is that if both players cooperate, they will have a reward, and if both players defect, they will have some kind of penalty. Then we also have the temptation and the sucker. This happens when one of them cooperates and the other one defects. So if I defect, I will be tempted to defect, because this is how normally works. So this is the temptation, and then if I cooperate and the other player defects, then I will be the sucker, because of course he played that one on me. So the question is, here we have temptation, reward, penalty, and sucker. What are the conditions that these 4 parameters must satisfy for the player to cooperate? And then what other conditions are necessary to guarantee that the game makes sense? For example, if the sucker means that we cooperate and the other defects. If the sucker is bigger than the temptation, then we will always defect, because it doesn't make sense. You know. So what are these kind of conditions? So let's start with, for example, T, the temptation, and R, which is the reward. Okay, the reward means that both players cooperate. So if the reward is bigger, and the reward is, so the temptation, and then the reward is that both players cooperate, and the temptation is that one player cooperates and the other one does not, and we are the player, and the temptation is for the player that does not cooperate, that defects. So what are the conditions that T and R must satisfy? Well, if the reward is higher than the temptation, this would mean that I will get always more benefit if I cooperate than if I defect. And if for both players this is the same, this means that they will always cooperate. So in the end, this will not be one of the conditions that make the game will make sense, because we are trying to make the game that sometimes it is worth to cooperate, sometimes it's worth to defect. So if they both get another a better reward to cooperate, then they will always cooperate and there is no game. Then we also need to find the condition between penalty and sucker. So the penalty, as I was saying, is that they both defect, and the sucker is that one defects and the one that cooperates get the sucker points. Here it is exactly the same as the temptation and reward. If the sucker points are bigger than the penalty points, then the game will not make sense at all. Okay. So the idea is that the penalty that we get for both players to defect will be higher, the number of points will be higher than the number of points got by the sucker. And finally, this might be a little bit also clear, but the idea is that the reward also needs to be bigger than the penalty, of course. So if both players cooperate, they will get more points than if both players defect. That is, for example, if we go to the prisoner's dilemma, where there are two prisoners, and they say, okay, the idea is that they put them in two different rooms, and they are trying to make them betray the other one, right? So they say, okay, if they speak, they will betray the other one, which means that this is the temptation, because they will get less years of jail. But if they don't talk, then they will get both of them will get less years. So that's more or less how this works. So if we go to the next slide, we will see with the things that I talk, that we need the temptation to be bigger than the reward, and the reward needs to be bigger than the penalty, and the penalty needs to be bigger than the sucker. Because these are just the rules. Here we have the explanation, for example. So the temptation is to be bigger than the reward, because if not, I mean, the world would be always a nice place. We will always cooperate, and it makes no sense. It's like, okay, if you don't talk, if you don't betray your partner, you will be, I don't know, 3 years in jail. But if you betray your partner, you will be 5 years in jail. Okay, then I will not betray my partner. Then, of course, exactly the same, it pays to defect if the players is equally mean. Yes. And then, of course, cooperation is going to do always better than non-cooperation, because this is about cooperating, right? And finally, an important value is that this was the other conditions that are necessary to warranty. That makes the game make sense, which is that the reward, the value of the reward must be always higher or equal to the amount of points that the sucker and the temptation divided by 2. Otherwise, we will not cooperate. Okay, so let's try this with values. Okay. We get this table with some values for temptation, some values for sucker, some values for the reward, and some values for the penalty. Good. So these 4. So what we can do is we can put this table into a different kind of table, which is this one, which we put cooperation, defection, and then and this is like now we are going to do this how many players we have. Okay, so this is the table as I was saying. So these are the values we get. For example, for the reward are 3 points, the temptation is 5, then we have the sucker, which gets 0 points, and then we have the defection, which is 1. And then we put this in the table. So for example, we have cooperation with cooperation, it's going to be 3 points. Cooperation with defections, the number of points cooperation gets is 0. If it encounters tit for tat, it's going to be 3. Then defection with cooperation, 5, because it's the temptation. Then defection with defection, they both defect, so they get 1 point each. And defection with tit for tat, in the first one, the defection will get 5 points, but then tit for tat will always copy the copycat. It will copy the other strategy, so it will get 1. Tit for tat, it will copy cooperation, so it will be always 3. If it's defection, it will copy defection, it will be always 1, and if it's tit for tat, it will be always 1. So let's try to calculate the cooperation gains for each player. And then where resides the advantage from tit for tat over the cooperation. So let's see. this is we saw this in the slides, but let's analyze it a little bit before. Okay, so we have T, which is the tit for so we have T, D, and C, as we can see here. Okay, tit for tat players, defection players, and cooperation players. So what is the gain for one person? If the person is cooperation, is the E sub C. Okay. So the number of players he can talk with is the number of players from tit for tat, the number of players from defection, and the number of players from cooperation, minus 1 because he cannot talk to himself. And then if it finds a player that cooperates, then he will get 3 points multiplied by the chances of getting a player that cooperates, which is this equation that we see here. Okay. Then, if he finds a player that defects, he will get 0 points. So we did not up this in the summatory. And finally, if he gets a player from tit for tat, he will get again 3 points, and then multiplied by the number of players. So you can see here how valuable this table is, because with this table we can see what is going to be the cooperation gains for each of the type of player. Okay, so this one would be for cooperation. For defection is exactly the same, but we have 5 for the cooperation players, we have 1 for the defection players, and then we have 1 for the tit for tat players. Okay, you can see that the denominator is always the same. Then for tit for tat, if we go to the table again, we had 3, 1, and 3. So this is what we do. We have 3 points for each cooperation player, plus 1 point for each defection player, and 3 points for each tit for tat player. Of course, you need to remember that this is going to be C minus 1, this is going to be D minus 1, and this is going to be T minus 1, because we cannot play with ourselves. We can just play with the rest. So this would be the cooperation gains. So if we go to the other question, is where resides the advantage from tit for tat over C, over the cooperation? Well, if we go to the table of cooperation, and if we go to the table of tit for tat, I think it's quite obvious that we get 0 points when when we play with the defection players in cooperation, because they will always cooperate. They are dumb. They just cooperate always. And however, if we are tit for tat and we play with the defection players, we will always get 1 point. So this is the advantage. So in the end, the advantage in the cooperation gain, here we don't have any term, but here we have this term, which we can see here. Okay, so now let's calculate also the cooperation gains with limited runs. So for this, let's say we have 20 tit for tat players, D defection players, then C 10 cooperation players, and let's suppose we have 10 runs. What would happen if the game is not played indefinitely? And what happens in the first round? How many rounds are needed for this behavior to change? So in here we are going to use a tool that I sent you already in our ComNets hub in Jupyter. So this you should have access to this program. Okay, and here we can, for example, we can declare the points of the game. You can change it. I mean, I don't know if you've never used this, but it's pretty easy. You just come here. For example, if we want to change this, we just do this, and then we just click here to run the cell, and now it's going to be C. It's going to be 6. Okay, let's just leave it at 5 right now. Good. We can continue. So what we are going to do is to define in a Python function the average of cooperation, depending on the number of cooperative players, depending on the number of defection players, and the number of tit for tat players. So we see the total opponents, which is this one minus 1, of course, and then cooperation gains versus cooperation, which is this R, the reward, then versus defection, which is the sucker, and then versus tit for tat, which is also the reward. We return this value. Exactly the same for defection and exactly the same for tit for tat. It is just the formulas that we saw before, but this time written in Python. So we run an example, okay, with 10, 10, and 20, the example we were saying, okay, and we see the average of cooperation, which is 2.2. Let's run this. Here we go here, here, and here, and then of course the average of cooperation is the same. Let's see what happens, for example, if the temptation is 6. So you can see that this changes. We run this the same, okay, and now the average, okay, for cooperation is exactly the same. Maybe this one changes because there is no, if you see in the cooperation, the temptation it's not there, which we'll see it in the defection and the tit for tat. So we run this. We have the average points for cooperation is 2.23, average for defection is 2.02, average for tit for tat is 2.48, and now we see that did this change a little? I did not check. Hold on a minute. Let me check it again. We run this and then run this as well. Yes. So we saw that, for example, here in the defection it changed a little. Okay. So I mean, if this is because we increase the temptation. So if we increase the temptation a lot, we will see that it is worth here to defect for the people that defect, and then the cooperation gain is always less. Of course, if we can also change the number of players, we can say that there are only 5 players, and we can run it again. I mean, we see that we change we see the cooperation gain changes, and oh, I forgot to do this. Yeah, true that. Good. And this kind of thing. Now we see that the cooperation points raise because, of course, less defection players means that there are many players cooperating, and the number of points is normally better. So the question is, we had 10 players here, 10 players here, and 20 players of tit for tat. I think, yeah, good. So now we are going to we are not going to have infinite runs, but we are going to add this n value, okay, which means that we will run this several times, okay. So n times, as you can see here, and also here, and also here. So what we are going to do is we are going to do a plot on how will this perform in every run. Okay, if you can see, the only difference regarding the number of runs is that in tit for tat, the first time tit for tat will always cooperate because this is how it is programmed. So in the defection versus the defection, tit for tat will have first a sucker value, which is 0 points, and then we will have always the penalty value. So for example, if we go, let's see here in the defection runs, okay, we have no, here tit for tat, for example, versus defection, okay, he will get P, but he does not in n-1 runs, because in the first run it gets 0, okay. So if we come here to the plot, we defined the average of cooperation, and then we get the points, and let's run this. We run the number of runs, okay, and then we just because this is just the plot with the functions. I think I don't know if I run this, so let's run this and run this. Good. And then we also run this to see the average of cooperations in, for example, 100 runs, okay, and we can see, for example, here that for cooperation is 1.9, 2.7 for defection, and tit for tat 2.3, and we plot it. This one for 10 runs. So we see, for example, here that the defection is getting a lot of points, way better than tit for tat and cooperate. I think this is because I did not change this. Let's run this again. I think I'm not. Yes. Okay, let's try it again now. Okay, that looks better. So we see that in the first number of runs, the defection starts winning. But of course, this is because it betrays the tit for tat players. In the beginning, the tit for tat players work as cooperation players, and this is why they start at the beginning. But then they get disadvantage over the defection players. And there's a point, in our case at the 5th round, where it is better to do the tit for tat than to do the cooperation. Mainly because the defection will always gain only 1 point against the defect and against tit for tat. But when we make tit for tat go together, their gain is going to be always more. Is going to be more. Is going to be the reward, which is 3. Okay. What was happening before? Now that I've changed this to 6, what was happening before? This is one of the conditions I was saying that must happen. Otherwise, it will always be worth to defect. The problem was that the temptation was too high, was that high that they will never want to cooperate. They always want to defect because the cooperation gain it's not enough. Good. As I said, this document, you have it online. You can access it. It's a very nice document that you can look into, and you can just give it a try, play with it, change the values, see how they change in the plot. You can always also edit the plot the way you want. Okay, this document is for you. It's a live document, so for you to play. You don't need to save anything. If you want to save it, you need to save it on your private computer, because when you close this, it disappears. Good. So I hope you like this session of exercises. And if you have any questions, you can always contact me by email or whatever it's needed. And yeah, I think that's all from my side. And I hope you like it. See you on the next one.